I'll show you how to use LTM Landscape Terrain Modeller for modifying floors for landscaping and terrain modeling in Revit. I have a sidewalk surrounded by two other floors. I have the plan view here to the right. And now I'm going to place a new sub-element in this floor with a base point in the other floor. I'll type in this slope. I use it to create sub-element in two floors. Select the floor which will contain the new sub-element and the floor containing the base point. Select the base point and select the position of the new element. LTM suggests that you place a new sub-element on the edges between the two floors on the line from the base point to the sub-element. See, now we have the new point in both floors and we have the same slope on those floors. If we want a grating in this lowest point of the floor, we insert, in this case, a generic model. It could be any type of family. Maybe we could rotate it a bit. In the 3D view, we can see that the faces around the grating is not in the same level because the grating is inserted in the lowest level in the floor. To avoid that, we have this match floor to grating and we select the grating. If the grating is hosted in the floor, the floor automatically creates new sub-elements around in the corners of the grating in the right elevation. If the grating is not hosted in the floor, you have to select the floor afterwards. When we're modeling in floors and we can annotate the sub-elements like this, we can see the real elevations. But if we manually with the standard tools in Revit modify sub-elements, this is not the elevation we will have to type in or look at, because this is the elevation from the baseline of the floor. If we use this sub-element in real floors, select the floor, finish selection, and we go in manually again. Now we have the right elevations of each point and we can type in the wanted elevation on each sub-element, on this sub-element in real levels. If we want to change surface for a part of the floor, if we have another surface but still want the same faces and slope, we can create an infill floor. Infill floor is a floor which fits perfectly into an opening in the main floor. To start with, I use Revit standard tools, vertical opening, select the floor, and then sketch the opening. It could be a shape like that or any other shapes. See if they have the opening, and then we'll create infill floor. Choose any floor type in the project, and if we include this inner sub-element, we will add a sub-element from the main floor. If we select the main floor, you will see there's a sub-element inside the opening, and if we select this one, the sub-element will be added to the infill floor. I can select the openings one by one. I can make a multi-selection. If the multi-selection contains only openings, all the openings will be created with infill floor. With there's no openings in the multi-selection, all openings in the floor selected will have infill floor created. a finish selection. So you can see the infill floor match perfectly the opening in the main floor. Of course, the infill floor can be updated so it will fit into the new geometry. If you want another surface, another floor type inside an existing floor, you can use infill floor. Infill floor will create a floor inside an opening, and you will preserve the edges and the faces from the main floor. I'll use Revit standard command for opening. Choose vertical opening, select the floor, and start sketching. It could look like that, or any form using arcs and lines. If you're using a circular opening, the sketches must be broken into 2 arcs. I close the sketching, and you see we have the opening in which we want to add the infill floor. You can see I have a sub-element inside the opening, and when I create infill floor, I select any floor type from the project. If I check this include inner sub-elements, the sub-element from the main floor will be added in the infill floor. Press OK, and now I'm going to select the openings by single selection or multi-selection. If I use multi-selection, of course there'll be created an infill floor in every opening. If there isn't any openings in the selection, every opening belonging to the selected floors will have another infill floor. I select this opening, press finish, and the infill floor will fit perfectly in the opening. If I don't want this inner sub-element or any other changes in the opening, I can use the update button. If I select the floor, the infill floor, I can uncheck the parameter include inner sub-elements, and when I update the infill floor, I have to select the opening, finish selection, and the floor will be updated to new geometry, and in this case the inner sub-element will be deleted.